So let's just bring together what we were working on in class today. That to finish up letter B, we wrote out our series for sine of x squared, we wrote out our series for cosine of x, and we used that to write the first four terms of f. So you could say that f is approximately equal to, so I'm saying approximately equal to because I'm going to chop off my polynomial. If I wrote all the terms to infinity, then I could use the exactly equal. But this is going to be, it was 1 plus x squared over 2 factorial. I'm copying it from the board, plus x to the 4th over 4 factorial. And then we had to get a common denominator. Remember, we're combining two terms that had an x to the 6th. And we got minus 121 720ths x to the 6th. So those are the first, sorry, that should say f of x. Thank you for your patience. I'm just double checking that that's what we really got. So that was our answer for the second part of part B. Those are the first four non-zero terms. So key idea in part B, it wasn't just taking the first four terms from the cosine series and the first four terms from the sine series. It wasn't even just taking the first two and the first two to get 4. I have to look for the 4 smallest powers of x that show up and make sure I'm combining like terms. So just notice when I get to part C, I didn't actually write, well, I don't have enough information about f to write a real Taylor polynomial from scratch for f, because I would need to know the first derivative and the second derivative and the third derivative and the fourth derivative of f, all evaluated at 0. And I don't know those. But now check this out. Because of the work we did, we sort of pieced together two Taylor series that we knew, sine of x squared and cosine of x, to get the first few terms of the f polynomial. We're going to be able to figure out what the 6th derivative of f should have been. It's kind of crazy, right? So just notice that the term that has x to the 6th in it, just think about how a Taylor polynomial is built. That's supposed to be the 6th derivative of f evaluated at, in this case, this is all about x equals 0. That's a 0. This should be over 6 factorial times x to the 6th. Wow, x to the 6th. So it turns out we figured out the term in the f polynomial that has x to the 6th multiplying in it. And we got negative 121 over 720 x to the 6th. Now, since these two have to be equal, I can use this to figure out what the 6th derivative of f evaluated at 0 is. Notice 6 factorial is exactly equal to 720. So you could multiply both sides of this equation by 720, and your denominators would cancel out. The x to the 6th on both sides is equal. So you're doing whatever algebra you have to do now to isolate this expression, the 6th derivative of f at 0. And notice that's the only thing not crossed out on the left, and the only thing not crossed out on the right is negative 121. So I would write the 6th derivative of f. We write that as f with it looks like an exponent, a 6, but it's not an exponent. That's telling me which derivative this is. It's because writing 6 little primes would look silly. Of 0. The 6th derivative of f at 0 equals negative 121. All right, so here we go. I've got a new function. I've got f of x is e to the negative x squared. And I'm going to ask to write the first 4 non-zero terms and the general term, that's pretty normal, of the Taylor series for f. So you could figure out the first 4 derivatives of f and use them back in that, remember this? I'm going to scroll all the way back. Is this about x equals 0? Good, about x equals 0. You could do this. you could find f of 0, you could find f prime of 0 and multiply by x, you could find f double prime of 0 and multiply by x squared and divide by 2 factorial, and you do that up to 4 terms, you would have the answer. Your life is a lot easier if you've memorized the Taylor series for the Maclaurin series for e to the x. So I'm going to circle it here. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. All right, so if you've done that, then we can write a transformation. We can transform that series to get the answer to this part A. So this is what I would write. You don't have to write this first step. I would write for myself that I know that e to the x equals 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus plus x to the nth over n factorial. Once you have that written, you can write the first 4. Notice I wrote 4 non-zero terms, and I wrote the nth term. I'm going to write a series for e to the negative x squared by going back to this series, and everywhere I see x, I'm going to replace it with negative x squared. So that's going to be 1 plus negative x squared plus negative x squared squared over 2 factorial plus negative x squared cubed over 3 factorial plus negative x squared all raised to the nth over n factorial. That's my answer to letter A. If that series had combined 2 series, it's kind of like the last problem we did. If there were like terms in there that you would want to combine them, or otherwise you wouldn't be giving the correct number of terms. But here you have no obligation to simplify. Notice that if you're about to move on to letter B, you might choose to simplify just because you're going to have to do algebra with these terms. It might work out a little easier, but totally up to you. That's the same as 1 minus x squared plus x to the 4th over 2 minus x to the 6th over 6 plus ... This is going to be negative x to the 2n. Oop, that's not true at all. Okay, when I think about taking negative x squared to the nth, that's negative 1 to the n times x to the 2n over n factorial. But again, this is not required. If it helps you, because it might help you in the algebra, feel free to. But you might like to box your answer at the end of question A to make sure you get credit for that, and then do the simplifying at the part of B if you decide that you need it. All right, so we're going to try this, see if it helps to have more space to do our writing. Our answer to part B was f of x was approximately equal to 1 minus x squared plus x to the 4th over, was it 4? No, it was x to the 4th over 2 minus x to the 6th over 6 plus ... And this was negative 1 to the n, x to the 2n over n factorial. So in question B, it says use your answer in part A to find the limit as x goes to 0 of 1 minus x squared minus f of x all over x to the 4th. Okay, so the idea here is f of x is infinitely long, but if you could write a certain number of terms of it and kind of get the pattern, you're going to be able to figure out what the behavior is. If we're going to be able to figure out what happens as x goes towards 0. Okay, so I wrote this. It's a little ugly because we've been asked to do infinite math in a place where we're not used to doing infinite math. We're used to having some number of terms and we can actually cancel and multiply. And but watch what happens. If I You see what I did? I took 1 minus x squared minus, and I replaced f of x in parentheses with the first several terms, the first 4 non-zero terms, and some dot dot dots in the general term. I've divided the whole mess by x over 4. So imagine simplifying the first few parts of this. This is going to be the limit still as x goes to 0. This one and this one are going to cancel. I'll use a different color. So this is 1 minus 1. This is negative x squared minus negative x squared. So negative x squared plus x squared. These terms are going to cancel. So the terms that are left over, the only thing left is this subtraction in front that's simplifying. So this now looks like the opposite, oops, we don't even want to use red anymore. The opposite of x to the 4th over 2 plus x to the 6th over 6. Oops, minus. And this is going to be, well, let's say plus dot 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 plus. Except it's really going to be minus now, because these are going to be opposites. So minus dot 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 minus negative 1 to the nth x to the 2n over n factorial, and everything here is getting divided by x to the 4th. Well, this term, negative x to the 4th over 2 divided by x to the 4th, that makes negative 1/2. And then look at what happens to the rest of these terms. Plus, look at that numerator. So I'm looking at x to the 6th divided by 6. That's really like the third term, so it's x to the 6 over 3 factorial. It's going to get divided by x to the 4th. Everywhere else, every other term that's there has x to a greater power than 4, right? So I'm going to be able to subtract the exponents. In this case, 6 minus 4, I'm going to have x squared over 6. You could try to write that. So I might even skip that term, and I'm going to say this is going to be minus negative 1 to the n, x to the something over n factorial, but I'm supposed to divide by x to the 4th. So I'm going to subtract exponents. This is going to be 2n minus 4. Look, I have no more x's in a denominator. That means I can replace all of my x's with 0. This whole shmla simplifies to 0, and I have a limit that's equal to negative 1/2.